Hey folks, welcome back to the day 6 video of the system design playlist. And in this video, we are going to discuss about the load balancing algorithms. First, we will discuss about the round robin. Then we will go to the weighted round robin. And after that, we are going to discuss about the least connections. Then we are going to discuss about the least response time. After that, we are going to discuss about the IP hash and then finally the summary. Before getting started with the algorithms, first let's understand the brief intro about what exactly a load balancer is. If I talk about a load balancer is a networking device, or we can say it is a software application which distributes and balances the incoming traffic among the servers. So it provides high availability and efficient utilization of servers and high performance, right? It works as a traffic cop. So if I talk about load balancer, what happens is, suppose you are requesting, like you are sending request 1, request 2, and then you are sending a request 3, right? You are sending this over internet. First, this request reaches to load balancer. So what happens is load balancer manages the traffic. Now there are multiple requests which are coming, right? So load balancer sends the request based upon which server is free to serve the request. Suppose this is a server 1, this is server 2, and this is server 3. This server is busy right now. These both servers are free. So the load balancer will send the request to them. Like a traffic cop, what does a traffic cop do? He used to manage the traffic, right? So he used to manage the traffic, sends the traffic on the way, which is free, right? We don't have so much load on that particular path. This is what load balancer is doing. Load balancer is also sending the request to the servers which are currently idle, which are currently not busy in doing any task. This is a basic architecture of load balancer, how it actually works. So suppose you have some client, this is 1, this is 2, and this is 3, right? You are sending some request over the internet. The request first reaches to the load balancer, and then the load balancer decides that to which server I shall send the request, whichever server is not busy, right? So it will send the request to multiple servers. This will increase the availability. It will also reduce the downtime. Why do we need load balancer? What are the issues without load balancer, right? So the first issue is single point of failure. What happens is if the server goes down or something happens to the server, let's say the server crashes, so the whole application will be interrupted. Your application was running on a particular server, right? And the server went down. So your application also got interrupted and it will become unavailable for the users for a certain period of time. That's why like we see so many times when we surf over the internet, we see there is a downtime. The server is not responding actually, right? So it will create a bad experience for the users, which is not acceptable. The second one is overload servers. So there will be a limitation on the number of requests that a web server can handle. If the business grows, let's say the business is growing and the number of requests increases, right? The server will be overloaded. Obviously, like first we were sending only 1,000 requests and now we are sending around 1 billion requests. So the overload is gradually increased. Limited scalability. So without a load balancer, adding more servers to share the traffic is very complicated. All requests are stuck with one server, and adding new servers won't automatically solve the load issue. Let's discuss the issues without load balancer through a diagram. So without load balancing, what happens is, let's say this is a client and it is sending a request, right? and these also sending the request to the same. These are also sending the request to the same server. The request is going to the server 1, which is in a condition of overload. Suppose there is a crash, like there is a crash, right, due to overload. So what is happening? This is causing a single point of failure. So this is causing single point of failure. Like this server went on a crash, and due to this server, all the services which were served to these clients, these went to a single point of failure, right? Whereas if I talk about the limited scalability, what is happening? We are sending all the requests to one server only, whereas these servers which we were using, which we have already added to our rack, like server 2, you have server 3, and you have server 4. These are idle, right? These are not working. These are not working. So why do I need all these servers? Why do I even need all these servers if I am going to do this thing? Like I am going to send this. So it is not creating any kind of availability. It is also increasing the downtime. It is causing a single point of failure and overload to a particular server. Now let's talk about round robin algorithm. This is the first algorithm we are going to discuss. So we have round robin algorithm. Suppose there is a client. The client can be your desktop application. You have client over mobile, right? Either you are sending the request from the mobile phone or you are sending from the PC. Okay. So the request goes to the load balancer. First, it goes to the load balancer. Suppose you are sending 6 requests. Let's say you are sending R1, R2, R3, R4, R5, and R6. You are sending all these 6 requests, right? What happens is, have you ever played cards? So what happens in cards are like, first in the first round, what we do is we serve to like particular user, like then we give the cards to this user and then this user. Again, we repeat the process. Like we again give to this user, and this user. This is the same procedure. So what is happening is, suppose the request 1 is coming, right? So you are giving the request 1 to server 1. Then request 2 is coming. You are giving the request 2 to server 2. Then request 3 is coming. You are giving the request 3 to server 3. And then again the same procedure repeats. So request 4 is coming. You are giving to server 1. Request 5 is coming. You are giving to server 2, and request 6 is coming. You are giving to server 3. So this cycle keeps on repeating. This cycle keeps on repeating, right? When to use RR algorithm? When to use the round robin algorithms? When all the servers have similar processing capabilities. What do you mean by similar processing capabilities? You have similar RAM, you have similar storage, you have similar GPU, CPU, and you have similar power capabilities. And these are also equally capable of handling the request, right? The response time, if we talk about the response time, that should be same, almost same, approx. We cannot say that it is always perfect, so it should be approx. When we need simplicity and even distribution of the load is more critical, right? Now let's talk about the benefits and drawbacks of RR algorithm. If I talk about the benefits, it is simple to implement and understand. It ensures even distribution of traffic, like even distribution. I was having 6 requests, right? So overall I was having 6 requests. Each server, let's say there are 3 servers. This is server 1, this is server 2, and this is server 3. So all these servers are handling the equal request because it is having 2 requests. It is also having 2 requests, and it is also processing 2 requests. So that is even distribution of traffic. If I talk about the drawbacks, so does not consider several load or response time. Yeah, it does not consider so many loads and response time because all the servers are having almost equal capability. can lead to inefficiencies if servers have different processing capabilities. It can lead to inefficiencies if your servers are having different processing capabilities, right? So now let's talk about the round robin algorithm. How do we implement round robin algorithm? So I have implemented it in Python. You can do in your choice language. So what we do is we have created a class of round robin, right? And then we have defined a function, like we are using constructors. So what we do is first we store the list of backend servers. How many servers do we have in the backend, right? And what we do is we start before index 0. So first call becomes 0. Like when we increment -1, it becomes 0. That is why we are keeping the current index as -1. And then we have defined the get next server. So what it do is it will give you the next server to which we have to move. So what we do is move to the next server in circular round robin order, right? And this is the logic behind it. Like what we are doing is self.current index plus 1 modulo length of current servers, right? And then we do return the server at the updated index. Okay, I hope it is clear. And let's take an example. This is an example. These are the list of servers that we pass. Like currently we have passed 3 servers in the parameters. Okay, and then our algorithm works. So what we do is like we simulate all the 6 incoming requests and get the next server in the rotation, and we print which server is selected. So this is the code for that. Let's try to run this code. Okay, so our code is working completely fine. What is happening is your request 1 is going to the server 1, right? And then your request 2 is going to the server 2. Then your request 3 is going to server 3. After that, your request 4 is going to, again, the cycle is repeated here. So cycle is repeating here. Request 4 is going to server 1 again, and then request 5 is going to server 2. Request 6 is going to server 3. Now let's talk about weighted round robin algorithm. So we have weighted round robin algorithm here. What we do is we are sending a request. The client is sending a request. First it goes to the load balancer, and before load balancer it actually goes to the internet, right? So we have already assigned some weight, like we have given weight 5, weight 1 and weight 1. So what is a weight? Weight means like how many requests a server can process at a time, right? So suppose the same, there is request 1, there is request 2, there is request 3, there is request 4, there is request 5, and there is request 6. These all are coming. First we have R1. So what we do is now we are not going to send the request one by one like we are doing in round robin algorithm. We are going to send these requests in chunks. Like we have chunk of 4 because there is a weight of 5 only. So we are going to send all these at a time to the server with highest weight. So it goes to the server 1. And then we have weight of 1. So we can only send one request at a time. So the request 5 goes to server 2 and request 6 goes to server 3. When to use weighted round robin algorithms? So when your servers have different processing capabilities or available resources, when you want to distribute the load based on the capacity of each server, right? So let's say you are using a server with weight 5. You will surely send more requests to it at a time, a big chunk, right? Rather than sending small requests. And if you are having a server with weight of 1, so you will only send one request. So based on the capabilities of the server, you are sending the request, like how many requests it can process and it can handle. If I talk about the benefits and drawbacks, weighted round robin algorithm balances load according to server capacity. This is a benefit. It balances the load according to the server capacity, and it is more efficient because we have like server resources. So we are using all the server resources. How we are using them? Because let's say we have a server of capability which is large. So we are using it at a time. We are not keeping it idle, right? If I talk about the drawbacks, so it is slightly more complex to implement than simple round robin, because it doesn't consider the current server load or response time. So it doesn't consider the current server load, what is the load on the server, and it also doesn't consider what is the response time the server has. Now let's talk about the implementation of weighted round robin algorithms. What we do is, first, the same, we store the list of servers, how many servers do we have in the backend, and then we have the weights. We are going to assign the weights according to their capacity, like to store the weight of each server, right? And then same, we are going to start the current index with -1, so that after increment it becomes 0, right? Current weight is termed as 0 because we are assigning dynamic weight that decreases each round. So in each round the weight is going to decrease because you are going to assign resources, so obviously the weight is going to decrease. Previously it was 5, then you have assigned 4 requests. Okay, so 4 request goes to server 1, so the weight is automatically decreased, so now you only have 1, right? And then we have get next server. Here what we do is we keep looping until a server is selected. Until a server is selected, we keep looping, like to find the next server. So we move to the next server in round robin order. That is the same. If we completed a full cycle, like if we have completed a full cycle, now what we do is we check and decrease the current weight by 1. Okay, like you have now assigned the resources, now you are decreasing the weight by 1. And then what we do is, if the current weight is already less than or equal to 0, you reset weight to maximum weight. If it becomes 0, then if this server weight is greater than or equal to the current weight, right? So what do we return? We return the server, and like we select the particular server on which we are currently and we return it. Let's say we have an example. This is server 1, this is server 2, and this is server 3. This is a list of servers and their corresponding weights we have assigned. Let's say we are giving 5 as the weight or capacity of server 1. This is capacity of server 2, and this is capacity of server 3, right? And then we call our function. After that, what we are going to do, we are doing the simulation, like we are serving 7 requests and get the next server. Then we are printing which server receives the request. Let's try to run this code. Okay, so we have successfully run our code. What is happening here is request 1 is going to server 1. As you can see, request 1 is going to server 1 because remember, server 1 is having a weight of 5. So we can send around 5 requests to server 1. So these all are going to server 1. Okay. And then you have server 2, which has weight of, server 2, which has weight of 1. So you are sending the 6th request to the server 2 and then 7th request to the server 3, which has same weight of 1. Next, we have least connection algorithms. So what do we do is, again, we are sending the request to the load balancer. The client is sending the request to the load balancer. So we have already assigned connections, like these already have connections, right? What we are doing is we are sending the request based on least connection. We are sending the request based on least connection. So this server 1 is having connection 10, which is least among all these. We are sending the request first to this server, and it is in ascending order. Like if once it is assigned to this server, then it goes to another one which is having least connections more than that. So like we have 50, then if suppose a request 4 comes or request 5 comes. When to use least connection algorithm? when you want to distribute the load based on the current number of active connections, right? And when servers have similar processing capabilities, but they may differ in levels of concurrent connections. What are the benefits and drawbacks of least connection algorithms? Let's talk about the benefits. So least connection algorithm balances load more dynamically based on the current server load. It helps prevent any server from becoming overloaded, and with a high number of active connections, right? What are the drawbacks? They may not be optimal if servers have different processing capability, because we have already discussed they are made for servers with similar processing capabilities, and these requires tracking active connections for each server. Like, we are sending the request, right, based upon the least connections, so we have to check which server has least connections, so we require tracking activity here. Let's discuss about the implementation part of a least connection algorithm. What we do is we import a random library, right? And we create a class of least connection, which holds the information about it. And then we have initialized the constructor. What we do is we have a list of servers, like we have multiple servers. We can have multiple servers. So we are storing in a dictionary. Create a dictionary where each server starts with 0 active connections, right? And then what we do is we define the get next server. So to find the which is the next server we have to serve based upon the minimum number of active connections among all the servers. Oh, so we have defined minimum connections is equals to like server dot values minimum among them, and then select all the servers that currently have this minimum number. So what we are doing is we are just creating a we are just collecting all the servers which are having minimum. Suppose you are having two servers with a connection of 5, right? Both servers have least connection of 5, so we are going to collect them, right? And randomly pick one server from the least loaded ones. So select server, and then you have a random choice. You can select any one of them because both are having 5 as least connections. So what we do is we increase the connection count for the chosen server, and then we return the selected server. After returning the selected server, we go to the release connection. So what we do is we decrease the active connection count when the request is completed, and then if the server is greater than 0, what we do is we just decrement the count by 1, right? Let's say we have an example usage. So we have server 1, we have server 2, and then we have server 3. Okay, this is a list of backend servers. And then we are going to simulate incoming request. So here what I have done is, like, I am using random. Why I am using random? I am using random to assign the connections. Let's try to run our code. So our code is working completely fine. So the request 1 goes to server 1. The request 2 goes to server 3 based upon the least connections. The request 3 goes to a random server with the least connection, and then again request 4 goes to some server 3. Next we have least response time algorithm. We are sending the request to the load balancer. First it goes to the internet, then to the load balancer. And here what we are doing is we have already calculated the response time. So this server 1 is having a response time of 5 milliseconds. Let's say this server 2 is having a response time of 1 millisecond, and let's say the server 3 is having a response time of 10 milliseconds. We are sending the request first to the server which is having least response time. So the response time of server 2 is the least one, which is 1 millisecond, which is less than 5 millisecond, less than 10 milliseconds. So we are sending the request to the server which is having least response time. When do we actually use least response time algorithm? When do we actually use it? So when you have servers with varying response time and you want to route request to the fastest server. Which one is the fastest? The one with 1 millisecond response time. What are the benefits and drawbacks of least response time algorithms? So let's first talk about the benefits. What does it do is it minimize overall latency by selecting the server with the fastest response time. It can adapt dynamically to changes in server response time, and it helps improve the user experience as well. Like, it is not causing any downtime, that's why it is increasing the availability of the server, and 24 by 7 it is available to us. So obviously it is creating a good experience, and it is also providing quick responses. If I talk about the drawbacks, so it requires accurate measurement of server response time. You need very approx, like to the point, right? Which can be challenging in distributed system, because what happens in distributed system, if I talk about real-time scenarios, we are not able to capture the response time of a server. We are not able to calculate what is the response time of the server. It depends upon so many conditions. It depends upon geographical conditions as well. It depends upon what are the capabilities of the server, right? So we are not, we don't have any algorithm yet, like who can describe, let's say this server is having 1 millisecond only. So 100% we cannot be sure. May not consider other factors such as server load, as we have discussed. It will not be able to consider like what is the load of the server or connection count. So now let's talk about the implementation part of least response time. What we do is we import the time and random. We have created a class of least response time. So we have the servers in the backend, how many servers we have in the list, and then what we do is we store the last response time of each server, right? And then we do the get next server. We find the next server which is the smallest or fastest response time from the list, right? So we are finding the minimum response time of the server, and then we get the, what do we get? We get the index of the server that has this fastest response time. So we return that server as the next server. Here we return that particular server with the least response time. So what we do is we update the stored response time for the given server, like what was the last least response the server has created, right? So we have index is equals to self.servers.index, and self.response of time of index is equals to the response time. What we do is we have simulated server response time function, simulate a real server delay using a random time between, let's say, 0.1 second and 1 second, right? Let's say we have created this as a delay. We have taken these values from our side. It is not a practical one. We sleep to represent actual processing time, and then we return the simulated response time. For example, you have server 1, you have server 2, you have server 3. Then we perform the least response time. So let's try to run this code. Our code is working completely fine. The request 1 is going to server 1, and it has count of response time, which is like it is taking 0.72 seconds. Server 1 is taking 0.72 seconds to serve the request. Then we have request 2, which goes to server 2. It has a response time 0.79 second. Then we have request 3, which goes to server 3. We have response time of 0.66 second, right? And so on. It is also calculating the response time based on the algorithm. Last but not the least, let's discuss about IP hash algorithm. Let's finally discuss about our last algorithm in the load balancing. So we have IP hash. We send the request to the load balancer. The client is actually sending the request to the load balancer over the internet. So what happens in IP hashing? It is sending the request based upon the index value. When to use IP hash? When you need session persistence, as a request from the same client are always directed to the same server. What is happening actually here? Like, you are sending request 1. So if again the request is coming from the same client, it will be served to the same server. Let's say there is client 2 which is sending a request. So the request is going to the server 2. If again the request comes, it will go to the same server. It will go to server 2. So like if you are doing session management, if you are doing login again and again, so your request is going to the same server, right? Like you are storing the cookies information, you are storing your password, you are storing your email. So it is going to the same server. What are the benefits and drawbacks of IP hash? Let's first talk about the benefits. So it is simple to implement. It is useful for applications which require sticky sessions. Here are some drawbacks. It can lead to uneven load distribution if certain IP address generates more traffic. So what it is doing is it can lead to uneven distribution. Let's say this is a server, right? So let's say this is client, right? This is a client who is sending request to this server, and again and again he is sending the request to the server. So the request is going to the same server based upon the IP address, right? It is going to the same server because we have done hashing. So again and again the same server is requesting the same client. Other clients are not getting even a chance for this server to become free and serve their request. So it lacks flexibility if a server goes down, as the hash mapping may need to be reconfigured. So we have to reconfigure the hash mapping. We have to update the indexing part as well. Now let's talk about the implementation of IP hashing algorithm. So what we do is we import the hash library, right? And we have created a class of IP hash. What we do is same, like we store the list of backend servers, and after that we find the next server. So how we are finding that? We are finding based upon the hash value. So hash library is going to give us the hash value. It is going to convert the client IP into MD5 hash string. So it is going to convert it into a actual string. And then we are going to find the index based upon the hash value. Now we have got the hash value. Based upon the hash value, this is the logic behind that. We are going to find the actual index. So what is happening? It converts hash from hexa to the integer. So it is converting from the hex value to the integer, and then we take modulo to map it to the valid server index, right? After that, what we are going to do, we are going to return the index. So we return the server selected by the hash. Let's say these are the examples. We have server 1, 2 and 3, and corresponding to that, what we are going to do, first we are going to run this IP hash. And if I talk about, let's say we are going to give some IP addresses before running that, right? We are going to assign some IP addresses. So these are the different client IPs which are making the request. Let's try to run this code. What is happening here is like based upon the hash value and the index value, the client with this IP address, this corresponding IP address, is sending request to server 3, and the client with this particular IP address is sending again to the server 3, right? And then we have a client which is sending request to server 1. Suppose we have this client which is sending again to server 3. Finally, we have come to the summary. So we have discussed about the round robin. It is a simple and even distribution, best for homogeneous servers. We have discussed about the weighted round robin. It distributes based on the server capacity and good for heterogeneous environments. Then we have discussed about the least connections, which is dynamically balances the based on the load, and it is ideal for varying workloads. Then we have discussed about the least response time. So it optimizes for fast response and best for the environments with varying server performance. Then we have discussed about the IP hashing. So it ensures session persistence. It is useful for stateful applications. Thank you guys. This was all about day 6 video. So I hope you like this video and you have understood all the concepts which we have covered in this particular video. Do like, share and subscribe my YouTube channel Code Muni, and we'll see you in the next video. Take care. Bye.